Again, Dustin, thank you for your session, for be here. Where are you from, Dustin?
Yeah, I live in San Diego, California, so right across the border from Mexico. So I get to jump over there and
Okay.
practice my Spanish, but a little ways from Peru. So thanks
Perfect.
for having me.
Okay, perfect. So, do you know Spanish?
Sí, hablo español, pero uh,
Poquito.
muy despacio, muy despacio.
Perfect. No, no. Thank you again, Dustin, for your session, for a share with us, with all the community. Um, Thank you again. Go with the session.
Thank you. Welcome. Thank you, everyone, for having me, and thanks for joining me for this session. What I want to talk to you about this morning is Azure Databricks for stream processing. We have a whole boot camp today of Databricks sessions, so I won't go too heavy on the Spark syntax, but I do want to call out what is important for streaming in Apache Spark, especially within Azure and on Azure Databricks. So you can please get in touch with me, connect with me on LinkedIn to find out any other YouTube posts and other sessions I get to jump into and to reach out with questions. I also post on Twitter, but LinkedIn is probably where I'm the most active. And you can go check out my website, dustinvanoy.com, to see blog posts and videos I do every once in a while that include some things about monitoring and other aspects of Apache Spark and Azure Databricks that we won't cover in this session today. Also, I forgot to mention, I lead the Data Engineering San Diego meetup group, which is still virtual, probably will be for a while on Zoom. So you're always welcome to join that. You can find us on Meetup and keep an eye out for topics you care about. And we always have group discussions. So you can come and ask your questions about data engineering across any platform, not just Azure. Here's our agenda mostly for today, for this session. We will talk about the shift to streaming, try and convince you a little bit that it is important to learn as data engineers or data scientists or others that are using Spark in particular. It's important to learn how to do stream processing. I'll talk to you a bit about what structured streaming looks like in Apache Spark. And then we'll look at a reference architecture and a demo in Azure where we use event hubs for the stream processing, and we'll use Delta Lake as the sink and talk a little bit about streaming into files with Delta Lake. So my main thing I want you to know, and we'll keep this part short, the main thing I want you to know is that if you aren't dealing with stream processing with real-time data, I think it's coming. I think it'll probably be something that you're looking at soon. And if you are already, great. Let's dig in and please follow up with questions, and I can get into more details for you for things I miss. But if you haven't started streaming yet, I think it's coming along. And the reason that it's important is that life doesn't happen, once a day, twice a day, like a lot of the jobs that I've written in the past have been. Life's happening all the time. Data's flowing all the time, and people are making decisions very quickly these days. So as data engineers, we may not all be data engineers in this session, but I am a data engineer. So I can tell you, I've had many conversations where I tell, my boss, someone very important in the business, that you don't need to do this in streaming. You don't need this every second or 10 seconds or minute. We'll give it to you twice a day, once a day. That'll be fine. And the reason I did that is because streaming was hard. I didn't know how to do it. My team didn't know how to do it. And it was going to be more costly, which still may be the case. But our customers and business leaders know that streaming is possible. Big companies are doing it. Small companies are doing it. All of the vendors, all of the companies that are selling platforms tell you that they can do it. So to walk around and say, we can't do this is not the best approach. It's still worth thinking about, is it going to be harder if we do this as streaming ingestion? So let's talk about this question. Is real time, is streaming data harder or easier? So I think typically for most teams, it is harder. And a lot of that comes with monitoring and keeping it running in production. However, I do want to say that dealing with really large data sets once or twice a day is not easy. We have, as a data community, we've gotten pretty good at dealing with large data sets and running 5-minute or hour-long jobs once a day. We've learned how to do that really well, but we also need to know how to stream the data that has some reason to be coming in quicker. So as we're dealing with that, we can process the data in smaller pieces, maybe even think of one message at a time, one event at a time. And your logic can get a little simpler and cleaner if you do that. If you're trying to do all of the processing in one go once a day, it gets a little bit muddy to figure out all of the stuff you're doing. It gets difficult to see, what am I doing to this data when I run this one job? You can actually break up the stream processing into more smaller steps. And because it's flowing so quickly, I think it keeps the logic a bit cleaner if done right. And then just another reminder, prepare for being able to do real-time analytics and real-time streaming ingestion. And the main thing I want to point out with this last statement is uh, it's okay if you aren't ready to show real-time Power BI dashboards or some other visualization. It's okay if you're not ready to do that. You still may want to think about ingesting some of the data in a streaming fashion. Pull it into your data lake streaming, pull it into your data warehouse in a streaming fashion. So what is Apache Spark structured stream? And I have a few slides on this, but I love this quote by Tathagata Das, TD, which is that it is fast, fault tolerant, exactly once, stateful stream processing without having to reason about streaming. There's a lot there. Let's break it down a little better than that. So why do we use Apache Spark for stream processing first, as we talk about structured streaming in Apache Spark? Basically, Spark became really popular as our mindset changed around big data, and we started to see the value in having systems where we can scale out. We can just add more workers, add more servers, virtual machines, some kind of processing compute power as we need it. And so Spark is a very fast and general purpose data processing platform that's set up that way. We can write pretty simple code. And if you don't already know Spark code, I think there's a few ways to get access to that today through this bootcamp. We can write pretty simple Spark code, and it's going to run on a cluster, and we don't have to think too carefully about how many nodes we're running and all of that. There's a little bit of thought that goes into it. And when you get to streaming, I think there's even more importance on thinking about how many workers you have, how much shuffling is going to happen. But it makes it pretty easy to get started. It's pretty easy to tune. And we have many options to write the code and run the code. So we'll look at Azure Databricks with PySpark, so Python on Apache Spark today, but we can use Scala or Java or some other languages as well. Just to remind you, so that simple code parallel compute, this is what we're talking about. You have your driver application or controller on controller node on Apache Spark, and it's going to split out a lot of your work onto the different worker machines or virtual machines, whatever it happens to be. With Azure Databricks, we configure this at the start, and it happens without us thinking too much more about it usually. A few more points from that talk and the link to that really good talk. You could probably just search for structured streaming Tathagata Das and find it too, is that it's really meant about you have this table that's constantly appended. So we keep adding data to a table in real time or near real time. And we deal with micro batches. So instead of dealing with one single record at a time, we might have 5, 10, hundreds of records at a time. Each of those sets of records is a micro batch. You can do continuous in Apache Spark. I think it's beyond preview now, but it's not something I've really been doing in production. So it's not something I will be talking much about today. So let's look at the syntax. And like I said, some of this is really familiar if you've worked with Apache Spark, even if you haven't used structured streaming. So if we have some kind of variable that's a data frame, or in this case, a streaming data frame, I'll call that df. And we're saying it equals, and we use the Spark context, which is in the Azure Databricks notebook, it'll be just called Spark, the Spark session, sorry. So spark.read stream. If you're used to reading from files in batch mode, it would be spark.read. All we're doing is switching to read stream. And then the format changes to Kafka is a pretty popular one, and we'll look at using Kafka and using event hubs with the Kafka APIs. And then you pass in your options. And those get a little tricky, so I'll hide that for a minute till we get to the demo. And then load tells it, this data stream reader is ready to go. Lots of transformations and things can happen that really look similar to batch mode, to regular Apache Spark without streaming. But I do want to call out that if you're doing aggregations and you're doing a group by, the windowing starts to become important. And I haven't included all of the different windowing options here, but I think the documentation is pretty good about that, and experimenting will usually help you find the window you want. But just remember, we're going to window our data, because if I'm doing the average trip distance or total distance, total cost, total minutes viewed, I don't want to do that for all time, all of my history, and just keep that running typically. I'm usually trying to see what is it for the last 10 minutes, 30 minutes, something like that. And this 10-minute window can say, calculate this for a 10-minute period, but you can still trigger it to recalculate every 5 seconds or 1 minute or something else that's different than your window period. So look at windowing. If you are going to do aggregations, it'll become really important. Happy to help answer questions, but I think the documentation is pretty helpful there if you get to that point. So then once we've done some transformation, maybe we've done our windowing and group bys, we'll write that data out. So one common pattern that's pretty simple is to write it back to Kafka or Event Hubs. When we write that data back, we're basically making it stay streaming and others can consume it. And we'll talk more about how that works in a moment. We'll have a similar set of configurations we pass in. And then with streaming, you will typically have a checkpoint location. I'd say if you're reading from Kafka, you'll want to have a checkpoint location. This is where it keeps track of what have you already read. And if you're doing streaming joins or really some aggregations where there's state that needs to be saved, it's saving information about what's already been calculated, what data has already been pulled in, then that'll get saved within the checkpoint location, or at least tied to the checkpoint location, depending on how you do it. So we have our format, we set our checkpoint, and then we can do start and we're ready to go. So if you've used Apache Spark, I'm hoping you're looking at this thinking, okay, this looks really similar. It's not that hard to switch from a batch job to a streaming job. Let's go into a few more options here, and I'm gonna call out a few things. So let's jump between a few of these new things I added to this longer list. Notice that I'm using the format Delta just to change it up, so we can stream data to Delta lakes. Usually streaming of files it's possible, but it's a bit tricky. Delta makes that a lot easier. It helps us clean up the small files we create later. So hopefully you can see that I bolded the trigger statement. And so when we're doing streaming, we don't have to. There's a default trigger, which will just keep trying to get data as quick as it can. But what we can do is tell it, hey, I only really need this to run every 5 seconds, 10 seconds, maybe it's 1 or 2 minutes. And if you're writing to files especially, that'll help you get more data in one micro batch, more data each time it reprocesses, and it'll give you less of a problem with small files. So in this case, I just say something like 5 seconds. If it takes more than 5 seconds to process the micro batch, then it doesn't matter. I've set it to 5 seconds. It'll wait until the first micro batch is done before the next one runs. So trigger is important to think about at some point, but you can get started without worrying about that one. Checkpoint location, I kind of already told you about. So something that sometimes it's required. I'd say you probably want to set it no matter what if you're doing structured streaming. But if you want to restart your job, or if you're going to make changes to the code, often you'll need to delete this checkpoint and start over. So that's something to think about when building Spark streaming jobs. And then output mode. And a lot of times we're using append, especially when going to Delta, I'm typically using append mode. Or there's another way I do it that we won't talk about today where I do an upsert. But typically I'm using append mode. And a few output modes I'll talk about is, this is really controlling. I have this table in the background that's continually updating with the latest data. That's kind of how Spark structured streaming works, remember? So as that table's updating, do I want to write to file, write to Kafka, whatever my output format was, just the latest batch of data, which append will do. It'll say all of the newest records get written. Or do I want to do something like recalculate the average and totals for that time period and write out everything? And so let's say we had video views, which I'll show a demo of, and we're calculating those by, I don't know, category. Is it a action film or is it a comedy film? If we're doing that, we could write out the latest calculated averages and totals by category every time that trigger runs. And that way you have that full set, and whoever's consuming the data would just drop the old stuff, take the new, and that's what you've got. There's also a mode called update that I find I often can't use. It's not compatible with some of the things I end up doing. But update mode would be anything that's changed or any new records. So it's kind of a hybrid or somewhere in between append and complete. But output mode is worth thinking about. If you just want to append everything, it should be easy. You probably don't need to do much there. Okay, let's get into some of the components around structured streaming with Azure Databricks. So you probably would expect we have source data coming from some different places. That's the easy part, I guess. We all probably have thought about and looked at source data in different places. So it might be coming from databases where we hook it up to stream into something, or it might be coming from the actual application itself. If you think about watching Netflix on, a TV or a phone or a computer, that web application is going to be calling some services, those services that drive the application that make Netflix work for you are probably producing records to something like Event Hubs or Apache Kafka. And I'll tell you more about why they do that, but they're sending it to this middle layer before Azure Databricks goes and reads the data. Then our structured streaming jobs on Azure Databricks can go pull the data off really quickly, right? We talked about every 5 seconds, maybe pull that data off, do some processing, and perhaps write it to data lake storage with Delta files, perhaps write it back to Event Hubs. A whole lot of options. We can write to databases. We can do a lot of the things you can do with Apache Spark. There's ways to do it with streaming. Some of them are easy, and some of them take a little more conversion back to batch mode right at the end using this command called for each batch. It's more of an advanced tip, but if you're having trouble figuring out how to write to something, you can look at doing for each batch and just using the normal data frame writer that you're familiar with if you've already done it in batch mode. So source data, Event Hubs, Azure Databricks is doing the hard work, and it's writing it somewhere. Often it's Azure Data Lake Storage. Okay, so I want to talk about Event Hubs for Kafka. And this isn't a full-blown course on Kafka or Event Hubs, so we'll keep it short. I hope that this helps with the why, though. So why are we going to use Event Hubs or Apache Kafka? I'm using those are kind of interchangeable technologies in a lot of cases. If you're used to AWS, they have Kinesis. If you're used to Google, they have PubSub. So these different tools, they basically are serving as a place that we can stream data to. The application itself, where you're watching your videos, where you're, clicking and buying things, they can stream data to Event Hubs, to Apache Kafka, whatever it is, and keep it decoupled from the destination, from all the things that need to consume it. And so Event Hubs, I think the way I like to describe it is a scalable message broker. We send a bunch of messages there. It holds on to them for usually some good period of time, a day, 2 days, sometimes longer. And it can keep up with all the data being produced, and it can keep up with all the consumers that are pulling the data off. So the benefit here, really the decoupling I'm talking about, is if I have 2 data feeds, in this case, I'm pretending like I'm using the New York taxi data set. If you haven't seen it, it's basically just taxi trip data. It's a really easy one to get your hands on in Databricks. If I have a trip data would probably come in under its own event hub or own topic. So it'd be its own data feed, its own stream of data into Event Hubs. Vendor data would be streaming into Event Hubs, probably a little bit slower. Every time one of our vendors, one of our companies that drives taxis changes, they would update the data via messages to Event Hubs. And then you can have a lot of consumers off of it. So in this case, you probably have a Spark structured streaming job that's loading up your data lake. That's how I would do it, at least. That's why I'm presenting this. You may have some real-time reporting that is a web app that reads directly from Event Hubs for the last period of time for the session that you're looking at and shows it on your web page. And you may have other user dashboards that read it either that, we saw earlier, it could be hitting Databricks to get the data and hitting the data lake to get the data, but there's ways to do it where the data is flowing from Event Hubs into some kind of dashboard. Other applications might be using it. If you're thinking of any kind of website like Amazon where you buy something, you make the purchase, that data might stream to Azure Event Hubs. It's a common architecture, stream that to Event Hubs. And then the fulfillment that actually goes and makes sure the seller knows to ship it and make sure that your order history gets updated, that could be pulling from Azure Event Hubs. So it breaks apart these different pieces of our applications and our data platform so they don't have to talk directly. Hopefully that wasn't too much detail. Hopefully that was helpful. This is a little bit more in the details, but I want to call this out, is that Apache Kafka, that kind of is the open source tool that we'll talk about a lot when we want to do this message broker. Jay Kreft's one of the founders of it, one of the creators of Apache Kafka, one of the founders of Confluent. He likes to describe it as a distributed log. And what I like about this is if you're used to SQL Server or other relational databases, you can just think about the fact that a transaction log in SQL Server is this place where you append events, and those events can then be created into the table, right? So if I know that I'm going to do an update here and then an insert here and then a delete here, by putting all those records in order, I could recreate the final data set. So Apache Kafka, Azure Event Hubs become really popular for data replication. they also give you the chance to replay the data, which you may have caught the way I was describing that. I could find out I've been making a mistake in my calculation and go back to the start of history in Kafka, which is usually fairly short. It's usually not going to be more than a week or a month, though I've had smaller data sets where we keep it for a year because that really helped our case. All right. Within Event Hubs, I want to clarify something in case you start reading more about it and get confused on what I'm talking about. Azure Event Hubs, if you go and search Event Hubs to create your own, then you're going to be creating an Event Hubs namespace, which is a collection of logs, a collection of streams. So going back one slide, this is kind of representing a single event hub or a single topic. Okay, so now we've got our trips data I showed would go to its own event hub, vendor to its own event hub, payments to its own event hub. And last I checked, it was about 10 event hubs that you can put in a single event hubs namespace. So when I say topic, I'm talking in Kafka terms, and we'll use the Kafka API for this. And if I say event hub, it's the same concept. It's this set of data. Now within each event hub, you can set partitions. And for most cases, you want to do more than one partition because it lets you consume that data with multiple processors. So if you think of running this on Apache Spark, let's say I have 4 workers, I'd probably want to have 4 partitions ideally. It's more like if I have four tasks that are going to be running in parallel, but I probably want to have about 4 partitions so that each of those can pull data. If I only have 2 partitions, then having 4 workers doesn't really help me for this particular job. Point being, partition 0, only one process can be pulling from that at a time, the way most things are structured. So a lot of times, if I don't know what I'm doing, if I'm brand new to the data and it's not super big, I'll start with 3 or 4 partitions. If I know it's a really big data set or we have bigger plans, then I might go to the max partitions, which still isn't that high on Azure Event Hub last I looked at what they support. So the partitions, multiple partitions make up an event hub, and orders retained within partition. So you'll set a key that drives the partition. If you're brand new to this, that's probably a little more detail than you need for day one with event hubs, but I did want to kind of call that out so you can kind of picture what it looks like under the covers. If you want to do what I'm doing where I use, sorry, that's probably fixed the sound. Sorry about that. If you want to do what I'm doing where you use the Kafka APIs with event hubs, then you would need to make sure you don't set up the basic tier. You need to set up the standard tier. And I make that mistake every time I redo this. So why don't we go into demo mode and I can talk through a bit more about what we're doing and show a bit about how we monitor this, which if you start doing this in your work, you'll definitely need to know how to monitor the data. Okay. So the first thing we need is to produce data, and we don't need to worry much about the code here. I just used Kafka client to run this. So we're going to kick off this cell to run and generate video views. So the same use case I talked about. We have some kind of application that generates videos. This will be a way to consume each video clip that happens. An event says, this person watched this clip at this time. We will be reading from, in this case, it's going to be Kafka, even though I'll show you the code for event hubs as well. I switch them out pretty easily. I just happen to be producing the Kafka today. A few setup things need to happen. These are pretty simple, but I'm going to do the imports I need with PySpark and set up my path. And then probably the more important part is right in here, 9 through 15, I'm going to set my Spark schema. And we'll do this because we need to convert from what I have as JSON messages into columns inside my Spark data frame. All right, so let me show you this notebook. I guess let me call this out in case you want to go find it right now. This notebook, if you go search GitHub for data kickstart and then find Databricks notebooks, you can find this notebook there. And so that would be a place to go if you want to go look at this code on your own and maybe pull it down and start to change some settings and run it. But hang with me. If you're going to do that, hang with me for a few minutes. Let me explain a few things for you. That'll probably help. So the next piece is going to set up some important pieces like the topic or event hub name. So I have a Kafka topic called video usage. And then you often have a subscriber group ID, a consumer group ID. And in this case, I easily change the version. That way it can start fresh at the beginning of the topic. Within this, we have two different ways, like I said, of doing this in Azure. If we were going to use Azure Event Hubs, with the Kafka API, like I like to do if I'm using Apache Spark, we would need to find the connection string from the event hubs. And if you go look around if you go look at your event hubs namespace or the actual event hub itself, you'll find this connection string is there. And what you'll want to do is put that in a Databricks secret scope. If you're not familiar yet, anything that's a password, anything that's sensitive, even if you're just playing around, I recommend not putting it in a notebook and having it in plain text. It's too easy to put that on GitHub publicly or show it in a demo like I'm doing today or something like that and give it up and someone could go and use your resources potentially. So create a Databricks secret scope. You can do it with Key Vault behind it or just a default one. In my case, the scope is demo. So if you're doing the same thing, you could create a scope called demo or change this to one of yours. And then I have a key that's sassle and then the topic name, but you could always change this to your own key. Okay, so we have a password. This special string, if you're going to go do this, go find this notebook and grab it from there. I don't know if it's in the documentation exactly this way, but basically what's happening is that big old connection string that we had gets passed in as a password, and the rest of this will stay the same for all or most environments. So then I build up my set of configurations. The things you would need to change is change this to your Event Hub namespace, and then everything else would have been changed in the password itself already. So that's how you get back the configurations you need to pass for Event Hubs. If you're using Kafka, I won't go too deep on this, but you'll have a username and a password that's a little bit separate instead. So the way we build that string for authentication is we pass a username and password separately. Bootstrap servers, or sometimes it's labeled as brokers, is the name of the resource you're using. So Bootstrap servers is basically my Event Hubs namespace name if I'm using Event Hubs, and in Kafka it's going to be the IP or host name of one of the broker nodes. All right, so in this case, we set the consumer config by using one of those two functions. And then here's where we get to the code I showed before. Let me just zoom in. Ooh, that's really big. Hopefully it looks okay for everyone out there. So the Spark read stream statement I said we would do, this looks, I think, exactly like my slide or really close to my slide. So we're reading that into a data frame here. And then we're going to set a new data frame called JSON DataFrame by doing a select statement. So there's two parts to this select statement. The first is a little bit complicated. Let's look at it one piece at a time. We are going to have this first item is give me the value out of the Kafka record. So this actually returns a Kafka record that has a key, a value, offsets, maybe a timestamp. So we're just going to take the value, which is stored as bytes, convert it to a string, and now we have a string of JSON. We take that string of JSON and convert it with this from JSON function that exists within the PySpark libraries. And then we name that column JSON. So we now have this JSON object, this struct within our data frame. And then we'll just take the raw string here so we can see what it looks like and kind of see what it looks like without that conversion. Then on the next piece, we'll create a new data frame called transformed, where we just do a select statement. And this is a pretty nice shortcut if you're okay with the syntax. Is JSON.star, JSON.asterisk will take each of those fields within my JSON struct and make it its own column. So what we end up with, we'll display this data in a moment, which will probably help. Let's go run this code now. The bottom piece is going to actually do the write that I showed you examples of earlier. Okay, so we're going to do a name, which you'll see why that's helpful when we go to monitoring in a moment, but it's optional. I'm going to use Delta Lake as the output and append as the output mode. The trigger is just like the slide. Checkpoint location, don't worry too much about it, except a little tip is that I change this when I'm messing around and changing the code a lot. I'll tend to reset the checkpoints pretty often, so I am not picking up with old code, old state, old information of the last job that ran. And then finally, everything really starts when we run start. So this is our action in this query. So we've basically been building up this explain plan for Apache Spark to run. As soon as we run start with the path to where we want to store it in Delta, in our Delta Lake, then we're good to go. So if you haven't done streaming with Azure Databricks yet, there's a really cool thing if you happen to do it in notebooks. To be honest, I don't use notebooks for my production jobs, especially streaming jobs, but when we are doing it in notebooks, they give us this nice chart that's going to show us some of the key information we need. All right, let's zoom out a little bit. I went too far in. There we go. So what we're looking at here is the blue line is our input rate. And so we're seeing we have about five records per second. It kind of tells us the answer right here is how I got that. And the processing rate, the orange line, we want to be higher than the input rate. So basically we're processing faster than data is coming in. Batch duration is really just a way to look for things slowing down. The first batch is always slow. And basically the only thing I care about here is if I see a spike that's, much more than 5 seconds, then something's going on. Maybe a task failed and it had to restart. Like this would be something where I might go look at the logs and see if anything's going wrong. If it's every once in a while, it's okay. Let's look at this other piece is the raw data, and the raw data is the query progress payload. And this also goes to our logs. I have a video I just released recently on YouTube about querying and log analytics. And at the end of it, I show how to parse this out of the logs and pull out a few of these values. So things like number of input rows per second, and what offset you're at, which I think is lower in my list. And if you're doing stateful streaming with streaming to stream joins, data operators is super important to keep an eye on. This information is available. This will just show you the latest one, but we can go get it from the logs. Okay, let's actually look at this data though, huh? I can uncomment 2 lines of this code and run this guy. It's actually going to look about the same as what I did this morning to make sure my demo was working for you. Again, I can see the stream job here. I don't really care too much about this. One thing to note, I guess, is that I'm doing a read stream from Delta. So I can stream data into Delta files and then stream data from Delta files, which is kind of new. I wouldn't have done this with Parquet data in the past. With Delta, I feel a little more secure doing that because of all the capabilities it adds. So here's my data. I've split out a bunch of data from the JSON, but then I can still see what that raw value looked like, right? And so it's just the same data still in a JSON format in the raw file. And this is updating every 5 seconds or so. So it just keeps changing the data on me. But that's our data flowing through Azure, throwing through, in this case, Apache Kafka, and coming back to Azure Databricks. Let's see, I want to show a couple monitoring things, and then I'll show you one other thing just to drive home a point I tried to make earlier. So driver logs are always helpful. That takes a little more time to make sense of that. What I want to show you though is if I go to the Spark UI, if you're not familiar, anytime you're using data frames, even if it's streaming data frames, the SQL tab has a lot of good information. It starts with my query name, which is nice. And let's see if I can find one that has good results. I've got a screenshot I'll show in a minute because I'm probably going to pick the Delta one. Let's see. Yeah, so this is just scanning the Delta table, I think, and figuring out what it needs to do there. I'll show you a screenshot that shows a little more interesting stuff happening. This structured streaming tab, though, is super helpful, and it comes, by default in Databricks. It's available in open source Apache Spark. It just depends on how you are running it. And within here, I can see I had a query running. I think this is the display query I started up from Delta. And then I have my named query where I actually specified the query name. Here I can click on, I see my overall stats here. I can click on Run ID. And from there, I can see input rate, process rate, input rows, which is the actual row counts, which for real data, I usually like this one a lot. I usually have some idea how much data should be coming in and find that input rows is helpful. Batch duration, like I said, I'm only looking for spikes, and even then I probably don't worry too much about it. And then this is just a breakdown of what's going on for each batch. And the first one's always a lot bigger, and then it should be fairly consistent after that. So there's your structured streaming UI. The other thing, I'll go back to slides and show you some more about monitoring in a moment. Let me try and jump over, hopefully this works okay, to one other notebook. I think this is a good example. One other notebook where we won't bother running this right now, but it's got a lot of the same types of setup. I wanted to show you that if we want to do a join, okay, one thing I want to show you is that even though I'm streaming, even though I've been doing this with a read stream to start it all off, I can still do with column statements, or I could do different transformations within my select clause. So I can use a lot of the same types of transformations and functions that I use if I'm not streaming, which is the thing I like about Apache Spark. It's really nice to do that way. And this may be the wrong file. So if you wanted to do a join, you can still do a join. But what I want to recommend to you is, if you're going to do a join, what I recommend is only do stream to stream joins if you really have a good use case for it. And you can go find, if you want to do stream to stream joins, there is a notebook that Databricks has out there for you. If you want to do stream to stream joins, go find this Databricks notebook. I happen to have made a copy in my repository, but it's not on my GitHub because it's not my code. They show this example where when you do stream to stream joins, ideally you can set up watermarks on both sides and time constraints. Where does it all come together? Right about here. They describe watermarks and all of the complicated things you need to do for stream to stream joins. What I really wanted to tell you though is instead of doing stream to stream joins, if you have one side of the data changes slowly, like vendor data in my example would change pretty slowly. Every once in a while, a company changes its name or I don't know, changes its employee count or how much they charge. In that case, I would go and use a Delta table. I'd stream that data into a Delta table, and then I'd use the Delta table as the right side of my join. And when I'm joining to a Delta table, that's not a stream. I'm just reading it as a data frame. That's going to actually avoid all the watermarking and things that I need to do. Okay, let's go back to the monitoring slides I have, and then I can see if there's a way for me to take any questions here. So I didn't find a good example on the SQL tab, but here's where when we're monitoring, still going into that SQL tab is pretty useful. And you'll kind of look for things like what type of join is happening. Are there exchanges, which is a shuffle? If you keep going down, you can see the actual query plan. We talked about the structured streaming UI. Don't forget to leverage this. Talked about the Databricks notebook. If you're streaming in a notebook, this is super helpful. It's great. The reality is, and I've got a whole YouTube series where I talk about this. The reality is you probably aren't sitting there watching even your structured streaming UI all day. You're busy doing other work, building your next Spark job probably. And so if this is a real scenario, what I like to do is go through the setup to get Azure Databricks connected to Log Analytics. And then I can use that to run queries against my Spark logs and see what's going on. This example doesn't show the query progress for my streaming example, but that's one of the things I can query. I can search for errors. I can have alerts that I set up on top of this to make sure that if something goes wrong, I get alerted about it. So that's the way to set it up for a real world scenario. There's other ways to do it, but I think shipping those logs out and having alerts set up is a really good option for you. Final thoughts for you. I actually want to, since we've got a little bit more time, I want to make sure we cover a super quick example of how Delta Lake helps us when we are doing streaming. I'm trying to remember if we still have a Delta Lake session later in the day, but it'll probably come up later in the day. I'll let others talk to you more about it then. I talked about Azure Data Lake Storage Gen 2. I think that's a really good spot to be writing data, though really that's kind of my final data when I'm streaming. I'd probably, if I have multiple steps in my processing, I'd stream it back to Event Hubs or Kafka, let consumers get it from there and keep processing in a streaming fashion. And then towards the end, I would go back or at the end of all that processing, when I've got kind of my final data set, that's where I'd write it to Data Lake Storage. Delta Lake's helpful for a lot of Apache Spark things, but the thing that's most helpful for us with streaming is compacting files. Well, I guess there's the ACID compliance pieces are really helpful because I can read and write to the same data set. I can have multiple things writing to that Delta table. And for the most part, I can avoid conflicts. And if I do have conflicts, I'll get errors and can actually fix them. That didn't used to be the case. So that's really helpful too. But one of the things that keeps us from streaming the files is that when we create a file every 5 seconds, or maybe multiple every 5 seconds, we end up with too much metadata about the files. Opening and closing files when we go back to read that data becomes a problem. The compression is not as effective when we have a lot of small files, especially if you're using Hadoop tools like MapReduce to read it. It's really going to be a problem, but it's going to be challenging with other tools that are built in Azure as well. So Delta Lake, I forgot my slide about optimize. Delta Lake has some commands, especially if you're working from Databricks, that let you optimize and vacuum out old files. And that's going to be something you'll want to do regularly if you're streaming the data. Basically, the thing that I want to point out from this slide for my talk is that because it's keeping it, Delta tables are keeping its own log and keeping a bunch of small Parquet files. What we're really doing is all of these small Parquet files will be created, and then Delta, when we run that optimize command, will go and create much bigger files off of all those small files we accumulated. And so that's kind of the magic of it, is that it knows which files we should read, and it's going to make bigger files for us to read. But you will want to clean up at some point. I think there's still a default in Databricks that'll take care of it eventually if you don't mess with it. So we actually, normally I do some Q&A and we go a bit. I'm not sure if they were really set up for that or not, but here's some references that I recommend for learning more about this. And definitely check out my notebook on GitHub. And if you go search for me on YouTube, you should be able to find my channel if you want to see more about Spark monitoring, or some of my other Databricks and log analytics stuff is what I've been talking about lately. And I'll be talking more about streaming with other platforms going forward is the plan. Thank you so much for having me. It's been an honor to present to the group today. And yeah, I think that's all I have for you today, unless there's any questions I can answer.
It was a fantastic session, Dustin, because I see that you have many experience with using Databricks and streaming scenarios, so it's perfect. Yes, I have some questions.
Mm-hmm.
For example, about the pricing. Let me 1 second. For example, how manage the cost using these scenarios in streaming? No, it's very difficult.
Yeah.
But if you have some experience.
Yeah. So the difficulty, and the question is about migrating from on-premise Hadoop, I think, into Azure Cloud. So I'll talk about both, I guess. So if you're using Databricks for like data engineering and data science work, and maybe your cluster auto terminates, like I always recommend to do, and it's off, half of the 24 hours because no one's working, then you're definitely going to pay more to keep an Azure Databricks cluster running. One of the reasons that I wouldn't run from notebooks is that there's different cluster types in Azure Databricks. And if you schedule a job that's your streaming job, which really it should just keep running anyway, or if you submit through a job API and spin up the cluster, you'll at least pay less for that cluster that's always on than you would if you go to one of your normal data science and engineering clusters and just keep it running all the time for this. So look at the different cluster costs. The other thing, the reason I show the monitoring with streaming, and I say that the hardest thing of streaming is, to me, is the monitoring and the productionizing of it and making sure it's going to work. Because yes, if your processing rate is way above your input rate and you're having absolutely no problems, you probably want to experiment with fewer worker nodes. And maybe I haven't really done it this way because I worry about the recovery and stuff, but you may even try going down to a single node cluster. That's not the normal case, but that's a possibility if you really don't have that much data yet. So definitely look at cluster size, running like in a data engineering, the job clusters versus the more interactive, more expensive clusters. And if you have, the main reason people would do things on premise or in some other kind of like Kubernetes environment where they're already paying for a bunch of resources and they have space, is yes, because it will, if you're already paying for resources anyway, then the cost becomes a lot bigger of a leap to make. Also, look at Event Hub cost. If you're going to do stuff with Event Hubs, look at that cost. Think about other options for running maybe Apache Kafka, and think about that cost, because depending on how you use Event Hubs, that can add up pretty quickly. So what I find though is that all of this stuff tends to get expensive when we want to do streaming. And what I've also found is a lot of this stuff gets pretty expensive with batch as we move more and more to processing a whole lot of data and trying to keep it more up to date. So I found I can usually control the cost to where we're not the one everyone's looking at asking us, why are you spending so much money? But it takes effort and it takes looking at what you're doing there.
Perfect. And yes, in my consulting experience, always the customer do the question, no, about Databricks. Is cheap or is expensive, no? And
What,
always the response is depend.
what, one thing I said recently is I've realized over the last few years that when I was leading a data engineering team doing Apache Spark that we managed ourselves, I think we totally should have paid for Databricks. So I make no money off of Databricks. I just like it. But like we would have probably moved a lot quicker and been a more effective team, provided more value, paying the extra money for Databricks. Maybe for streaming, we would have had our own thing for streaming. That's very possible. I think that's a real consideration. But doing it within Databricks certainly would be a lot easier than running this on your own, at least if you work with operations teams that aren't used to running Apache Spark or Hadoop.
Yes, it's more easy. Perfect. And there are some questions here about the demo, no? If the people could replicate then this demo using, for example, not even Hub,
That's a really good
using IoT
question.
Hub.
So my understanding is you should be able to do it very similar with IoT Hub. I can't remember if it supports Kafka API or not. So if anyone knows, pop that in the chat. I'll try and go search that one, but I'll wait till we're not live and search that one. So that's a great question.
I think that yes, because when you use a IoT Hub, you have an endpoint with a name of Event Hub, but
Okay.
I don't know. I have to try
Yeah,
it.
I find that a lot of the Service Bus, IoT Hub, Event Hub, they're very connected under the covers, but I haven't tried it, so I don't want to say that's for sure.
No, but it was a good question. Again, Dustin, thank you for your session, for sharing with all us. I hope that uh, have you in other session here with Peru BI community.
Oh, I'd love to. Thank you so much.
Thank you, Dustin. Thank you again. See you.
See ya.